logic, as well as it will have some repeated code. So therefore, it is better that you divide the main idea of your problem into a small pieces called subtasks, and then solve each subtask separately. I mean, find a solution for each subtask. After that, write the code for each subtask and define a method that represents the code of this task. It is quite often, but not always, that the solutions to subtasks are implemented as private helping methods. If a subtask is large, you divide it into smaller subtasks and solve the subtasks separately. These subtasks may be further decomposed into even smaller tasks, but eventually the tasks become small enough to be easy to design and code. Furthermore, if your program is having a bug that is a logical error, then it is easy to locate the code that is creating the bug, because the solution of the problem is decomposed into smaller tasks, and for debugging, it is fast to locate the code that is generating the bug. When the solution of all these subtasks are defined as methods, then the final solution is produced inside the main method by combining all the codes of these subtasks by calling or invoking the methods that are solving the subtasks. After writing the methods for each subtask, we need to test that each of these methods is free of bugs and is correctly solving the subtask problem. And this can be achieved by using a smaller program that is called a driver program. If we have more than one method, then we have to test each method separately. So in this case, every method you write should be tested separately to make sure that it does not have any bugs and it is correctly solving the task, which is the solution for the subtask. In other words, it should be tested in a program in which it is the only method that has not been fully tested. Let me show you an example on how to find a solution of a problem by decomposing the problem into small subtasks and find a solution for each subtask and combine them inside main by calling or invoking their corresponding methods. Our main problem is to write a method that displays all prime numbers between two integers given as parameters. A number is a prime if it is an integer greater than 1 and divisible by 1 and itself only. The smallest prime number is 2, next is 3, next is 5, 7, 11, 13, and etc. All prime numbers are odd, except 2 that it is even. Now to write this method as the main task, we will break the problem or decompose it into two subtasks. The first subtask, we are going to design a helping method that is called isPrime. The purpose of this method is to tell us if an input parameter is given to it, whether that input parameter is a prime or not. If the input parameter num is prime, then it returns true, otherwise it returns false. So that means the return value for this method is Boolean. The second subtask is to design a method called writePrimeNumbers, and it takes two input parameters. This method will write prime numbers between these two input parameters. The first one is a lower bound, the second one is an upper bound. So this is like a range. Lower bound should be smaller than or equal to upper bound. This method is going to use the method isPrime that was designed in subtask 1. So it will have a loop. It will go over the numbers from lower bound to upper bound. Any number in this range will be supplied as input parameter to isPrime. If isPrime returns true, then this method writePrimeNumbers will display it on the screen. Otherwise, it will skip it. Let us see the implementation of these two methods. The two methods are defined as static methods and they are placed in one class called prime numbers. So if we want to use these two methods, simply we write the name of the class followed by dot followed by the name of the method. For write prime numbers method, as mentioned here in subtask 2, it is using the method designed in subtask 1 called isPrime. So it has a loop that goes from lower bound to upper bound as input parameters, and in each iteration it supplies this number as input parameter to isPrime method. IsPrime method in return will check for the input parameter number. If it is a prime, it will return a true, and write prime numbers will display it on the screen. Otherwise, it will skip it. Now for isPrime method, it has an input parameter number. We assume here that number is positive, greater than 1. So first it will check for number. If it is less than or equal to 3, that means if it is 2 or 3, then it is a prime number, and therefore it will retain the value of OK as a local variable, Boolean local variable, initially is equal to true. Otherwise, it will try to check on numbers from 2 up to half of number. Any number in this range divides the input parameter, then it is not a prime number, and therefore the local variable OK will be changed to false. And when we go back to the beginning of the loop, if OK is false, we will exit the loop and return false as a return value. However, if it is a prime number, and then notice that I will go from 2 up to the half of the number. So 2, 3, 4 incremented by 1. Any of these numbers, if it does not divide number, then the value of OK, which is the local Boolean variable, will never change and it will be true. And therefore, how we will exit the loop? We will exit the loop when the value of I is greater than half of the number. After writing the code for each of these subtasks as methods, now we need to test these methods that they are working correctly as described and designed in their corresponding subtask. We will write a driver program for each of these methods, and we will check whether each of these methods are working correctly or not. The first driver program is for testing the first method, isPrime. Now, if you want to write a driver program for method, then you need to test this method on multiple input. So therefore, we are going to create a loop that repeatedly asks the user for an integer, and this integer is given to the method, and we check for the return value from this method. So first we will display a message testing a number is a prime or not. So this is telling the user that this is a test drive for the first method. Inside the loop, we will ask the user to enter a value of integer. Next, we supply it to the method isPrime. Notice that how we are calling this method. We are calling this method by writing the class name followed by the name of the method. Why? Because this is a static method. Therefore, you can call it directly from the class. And then the return value is saved into OK. Now this OK, which is a Boolean variable, a local Boolean variable, is tested. If it is equal to true, then it will be printed that this number is a prime. Otherwise, it will print that this number is not a prime. Now to test for the method for another number, then you need to ask the user, do you want to test again? And here we are going to read a string from the user, whether to say yes or no. So we are going to read it into a string called response, and we will test for response. Notice here we are using equals, ignore case for yes. So if the user types yes, then the loop will go back and repeat the same process by asking for another number, supply this number to the method, test for the return value of the method. If it is a prime, print it is a prime, otherwise print it is not a prime. And at the end, if the user types other than yes, it will exit the loop and the testing is finished. The second driver program is for the second method, write prime numbers. Similar to what we have done for the driver program for the first method, if we want to test write prime numbers method, then we have to repeatedly asking for two integers and supply these two integers to the method and observe what is printed on the output screen. So we have a do-while loop. First, in the beginning, we will display that this is a testing program, and then inside the loop, as we said repeatedly, we will display a message to enter two integers, and we assume here that the user will give us number 1 smaller than number 2. Then these two numbers are supplied as input parameters to the method write prime numbers. And then we will observe the output that is generated from this method, whether the output generated is correct or not correct. And if we want to test the method again, a message will be displayed on the screen by asking the user, do you want to test again? And the user here is supposed to type yes or other words than yes. If the user types yes, then it will repeat the same process by asking for two numbers, supply these two numbers to the method, and check for the output generated from this method. When the user types other than yes, then it will go outside the loop and will terminate the program and display that this is the end of the test.